Hi teachers, the math coaches and I are glad you're here for the explanation of rotations PD part 2. So let's get started. When we ended part 1, we had already gone through 3 of the 5 rotations. We had explained fact fluency, unit of study, and the digital rotations. So the 2 rotations left to go through are problem solving and hot topics. Problem solving is the rotation that we often get a lot of questions about. So I'm going to show you how I introduced this rotation in my own class and some of the success that I had. The first way I introduced problem solving was to my whole class. Instead of viewing it immediately as a rotation that they were going to complete on their own or with a smaller group or partner, we looked at it as a whole class approach. So I first introduced the idea of struggle time. The idea that whether you are a kindergarten, first grade, second grader, all the way up to a fifth grader and beyond, it is okay to feel struggle. It is okay to feel as if you look at a problem and you do not immediately know the answer. I taught my class that anytime we looked at a problem for problem solving, they were going to start with what I called struggle time. During struggle time, students sat, they silently worked in their head. I always had a visible timer that just showed the students that if you are really struggling and you feel like you are at a complete loss for where to go next or where to even start, you could look up at the board and you could see that there were only 2 minutes left, and at the end of that 2 minutes you were going to move on to the next part of problem solving, and they didn't feel like she's really going to make me just sit here and struggle forever. Again, it was a silent work time for students to just be thinking in their own head, how would I solve this problem? What would I do first? How would I go about this problem? Lots of strategies, lots of solutions you're going to see during this time. But me as a teacher, as I was walking around during struggle time, the only thing that I would do would be asking questions. So if they said, hey, Mrs. Alasso, is this right? I would say, well, what have you done so far? I would ask them things to encourage their thinking instead of confirming, yes, you're right and you're done working, or no, you're not right, and then maybe having a shutdown from that student. After their struggle time was over, we moved into a partner share. During the partner share time, again, I had that visible timer so they could divide that time evenly between both of them. It was a time when they were explaining their thinking, describing the strategy that they used, sharing what their answer was. It just kind of depended. Each day I would ask them to use partner share for a different purpose. I would again be asking questions to clarify during this time. I would encourage students to ask each other questions to clarify, and sometimes we would even play a game called Convince Your Partner, or I've heard it called Convince a Skeptic. And I would say today during partner share, you have to find a partner who got a different answer or used a different strategy than you, and your job is to try and convince them of the work that you did. And a lot of times students would try and convince, and that was when they would realize, oh my goodness, I had made a mistake, and there was a lot of great thinking that could come from that time. The last thing that we would move into after the struggle time and the partner share was a whole group discussion. So I would either ask them to bring their work to the carpet or display their work at their desk, and we could do a work walk around the room where students were able to look at everyone's work. Sometimes I would have students show their work using a document camera or utilizing Canvas, asking them to upload a picture. And again, I would really only be asking questions for further clarification. So instead of saying you're right or you're wrong, asking those questions to encourage students to explain even further, or helping students to see how they could come to realize their own mistake or realize confirmation of their work on their own, and that they didn't always need me for that. So once as a whole class we had really developed a good routine for problem solving, I was then able to move into problem solving as one of the 5 rotations. We have a really great resource called Exemplars learning that you should have a login and a password to access some problem-solving problems. A great thing about exemplars is that you will find you can select a grade level, you can select a specific concept or content area, and it will give you 3 levels of the same problem. So I think one is called a more accessible level, which would be the easiest level, and one is called a more challenging level, which would be obviously the hardest level. So the nice thing about exemplars is it gives you the leveled problems, but within the 3 levels of a specific problem, students are going to be working on the same thing. So the example that I have here in front of you is called coins in a bank. So whether I am a student working on level 1 or level 2 or level 3, my problem will be titled coins in a bank, and I will be working with coins. So it's nice for students that may get a little uneasy seeing that, oh, I'm working on coins, but they're working on geometry, and does that mean that I'm at a lower level or that I'm at a higher level? And it creates a little bit of equity with all of your students knowing that, oh, we're all doing coins in a bank, we're all working on counting coins. So with these 3 different levels, you can help students to work at their appropriate level. If you feel like a student is not challenged enough, you can take them to that next level. If you feel like students are a little bit discouraged, you can take them back a level. I also showed you with some pictures here how the different levels could also take students through the progression of the concrete, the pictorial, and the abstract. So for level 1, maybe I'm asking them, I want you to solve that concretely, and they're having to get out their 5 pennies and get out their 3 dimes to actually show me how they solved. At level 2, I may say, I want you to do this one pictorially. So maybe they just have to show what the different coins are worth using dots or their picture. And then maybe on the last level, I can say, try this one abstractly, try doing a number sentence to see how well their level of understanding is. This is a great tool to use for the problem-solving rotation, but the way I introduced it as a whole class, it really helped to set up what students would need to do when they were involved in problem solving as a rotation. So I could encourage them again, when you read a problem, think about that struggle time, kind of work to yourself, try and get as far as you can, and then maybe go find someone else who's at the problem solving rotation and have some of that partner share time. Try and convince them if you had a different answer, or really listen and question their strategy. So I think it was a very great way to introduce problem solving by first teaching what they should be feeling and what they should be doing every step of the way, and then giving them the independence to work on it as a rotation on their own. Last rotation is the Hot Topics or the Hot Topics review rotation. So some examples of work that I had with my first graders. I had a review unit over 2D and 3D shapes. So they would click to listen to a song about 3D shapes, and then they played a game to review identifying 2D shapes. So I could easily differentiate what level they were at for the game or which song they were listening to allow for that differentiation. Another example, let's look at our counting coins one. I could do a video reviewing the different coins and their values, just like I had used during my mini lesson when it was their current unit, and then a task, complete a coin counting activity. So that could be an online game. It could be baggies of coins that I had already created. Lots of different options there for what rotations could look like. And again, these are just some examples of things that I did in my own classroom, which was first grade. So to finish, just wanted to pull up those consistent practices again, just reviewing when you are planning your rotations, keeping in mind these things, and you'll be very successful. So incorporating the math process standards, encouraging students and creating the habit where they take their toolkits with them to any and all rotations, encouraging an environment where students are working independent of you, so teaching them how to troubleshoot if there are issues, what to do if they're not sure where to go, what to do if they have finished something, teaching all of those procedures ahead of time so that when rotations are up and running, you can focus on small group. The idea of activities and practice as opposed to assignments. So instead of thinking of they're going to go to Hot Topics and complete this, they're going to go to Unit of Study and complete this. An activity, a game, a practice that can be ongoing, never ending, and an activity that maybe they could do on their own with a partner or with a group. The rotation time being uninterrupted minutes. The use of the common vocabulary for your rotation names, that's going to help provide that consistency. It's also going to help you to know what it is that your students are working on and help them to better understand what it is that they're working on at each rotation. And the last thing, keeping in mind that the digital rotation, which should be the adaptive feature of DreamBox, should be completed every single day by every single student in your class. So good luck with your rotations and hope you found this to be beneficial.